All right, section 9.4, ionic bonding, the second to last section in chapter number 9. Electron transfer is what takes place in order for an ionic bond to be formed. Metal atoms can transfer electrons to nonmetal atoms to form ions. These ions attract each other due to opposite charges forming ionic bonds. A sodium atom forms a sodium ion. The electron configuration changes from, listed right here, to this, 1s2, 2s2, 2p6. So the 3s electron has been lost. Well, where does that electron possibly go? I'll tell you where it goes. It goes to the chlorine atom, which accepts it as one of its own and has now become a chloride ion. With an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6. When forming ionic compounds, atoms tend to attract or accept or donate electrons to achieve the electronic structure of the nearest noble gas. Now, an ionic lattice, not to be mistaken with ionic lettuce. Lettuce is a vegetable. An ionic lattice is kind of your visual. Individual pairs of ions do not bond together. Rather, huge number of both types of ions form this 3D lattice, this 3D structure. The chemical formula of an ionic compound indicates the simplest ratio of the two types of ions in the lattice. So essentially what this means, if you have sodium chloride, you don't have one sodium ion and one chloride ion. You've got 10,000 sodium ions and 10,000 chloride ions. That's a 1-to-1 ratio. The lattice is held together by electrostatic attractions between the many oppositely charged cations and anions. It's very different from a molecular compound because you're not going to really be able to distill it down to those basic parts. So here's an example of the ionic lattice structure of sodium chloride. We've got a sodium ion and a chloride ion. And there's a typo right there. That should be a negative. Oof. Okay, so this is one part, but they're kind of making this complex network with one another and connecting to one another and everything like that. So that's your ionic structure.